the first example is 2 over x squared plus 9x plus 20 equals 1 over x squared plus 9x plus 20 minus 5 over x plus 4. So as I'm looking at this particular problem, what is the first thing that I'm going to have to do in order to solve it? Factor what out? The quadratics, they're the same, so when I factor one, I'll have factored both, which is awesome. So when I go to factor this out, I'm looking for two numbers that multiply together to get 20 and add to get 9. I'm pretty sure Camden already said what it was, which 4 and 5. So that means when I factor this out, I have 2 over x plus 4 times x plus 5 equals 1 over x plus 4 times x plus 5 minus 5 over x plus 4. How is factoring this out helpful to me? Okay, so it allows me to look at all of my different denominators and see what they do or do not have in common. So I notice that all 3 of my denominators have an x plus 4. 2 of them also have an x plus 5. So what do I need to multiply into that third fraction in order to make my denominators the same? X plus 5. What we multiply into the bottom, we also multiply into the top. So I am multiplying both the top and the bottom by x plus 5. When I multiply it in, I will just have to distribute this 5. So when I do, I'm left with 2 over x plus 4, x plus 5 equals 1 over x plus 4, x plus 5 minus 5x plus 25 over x plus 4, x plus 5. What do I do next? Distribute the negatives because I need to simplify that right-hand side down to one fraction. So when I distribute that, I'm going to have 1 minus 5x minus 25. My left side will stay the same. My negative 5x will remain the same, and then I can combine the 1 and the negative 25 to get negative 24. Still over that denominator. What was the purpose of simplifying the right-hand side down to one fraction? How did that help me here? All right, so what is my next step here, Camden? Canceling out my denominators because they're exactly the same, and I only have one fraction on each side. That's the whole reason that we simplify both sides down to one fraction. So that when I simplify them down and their denominators are equal, the denominators cancel out. And then I'm left with 2 equals negative 5x minus 24. What do I need to do next? When I do, I get 26 equals negative 5x. And then what? Divide by negative 5. So I get negative 26 over 5. That does not reduce, but that is what my x is equal to. How do we feel about that? Great, not great, terrible, worst thing ever.
I just don't want to do this at all.
Nobody ever wants to do it, honey. We just do it anyway. Anybody confused by any part of that? Okay, we are really just going to do one more, and I think that will be enough. And then the rest of class will just be homework time. The hardest for yesterday.
Oh, that's kind of out of it.
Nice.
That's gonna be hard to get.
I don't know, maybe not.
Today is the day she sets me over the limit.
This is the hardest that it will get. Really? No, all together.
Oh, yeah, because
Don't be mean.
you need to natural.
Be nice. Okay, let's go ahead and take a look at this one. Who has an idea of how we would start this? I just heard two things. I heard factor, and I heard rainbow.
Yeah, fact.
Do I actually have to rainbow? I can take a 3 out. Before we ever attempt to rainbow, I should always look to see if I can take a common factor out of all 3 terms in my trinomial or in my quadratic. Okay, so in my first one, can I reduce this first denominator at all?
Yes.
Yes, by doing what? Take a 3 out. When I take a 3 out, I'm left with n plus 4. We're going to look at the same thing in the second one. I can go ahead and take a 3 out of 3, -6, and -72. And when I do, I'm left with n squared minus 2n minus, yes it is. I also know that this one over here will be exactly the same. Are all of my denominators broken down into their smallest elements? No, I still have 2 quadratics left. So I still need to factor that n squared minus 2n minus 24. So what 2 numbers multiply together to get -24, but add to get a -2? -6 and 4. So these break down even further into 3 times n minus 6, n plus 4. How is this helpful to me? Yes, Ebony.
You can take that -6 and multiply it to 1/3n plus 4.
Good. So I'm easily able to compare my denominators. I notice that every single one of my denominators has a 3 and it has an n plus 4. These 2 also have an n minus 6. So I need to take an n minus 6 and multiply it into the top and bottom of this first fraction. So I'm going to go ahead and rewrite this with these simplified denominators, as well as multiplying the n minus 6 into the first one. So I have n minus 6 over n minus 6 times 1/3 times n plus 4 plus 4/3 times n minus 6 times n plus 4 equals 1/3 times n minus 6 times n plus 4. So I left the denominators in their factored form, and then I multiplied n minus 6 over n minus 6 into the first fraction. Remember, when we're multiplying into such a complex denominator like that, we don't have to FOIL it. We can just multiply it in and leave it as the product of these factors. So I can leave it still in that factored form. I do, however, have to multiply it into the numerator. So when I multiply n minus 6 into the 1, I am left with n minus 6 over 3 times n minus 6 times n plus 4 plus 4/3 times n minus 6 n plus 4 equals 1 over 3 times n minus 6 times n plus 4. Give you guys a second to catch up. What am I going to do next? Divide my two fractions? Combine. Okay, so which two fractions? Do I just get to pick two at random? Ooh, which ones are we going to pick? Okay. Why did you pick those two? Can we actually pick two fractions at random? No, we have to combine the ones that are on the same side of the equal sign. So he is correct. We are going to combine the n minus 6 and the plus 4 because they're on the same side of the equal sign. When I combine them, I'm just combining their numerators. So what's n minus 6 plus 4 going to simplify into? N minus 2. I also know that it's going to become this denominator, and then my denominators will be the same. So I can actually just skip right to the step where I cancel those denominators out and then finish simplifying for my variable n. So what is n going to equal here? 3. And that's my final answer. This is as complicated as it gets. This is the worst of it. Okay, having those wonderful quadratics in there. So the rest of class is homework time for this. As a reminder, tomorrow you will have some homework time, but then you will also be starting the review for the test, which will be next Tuesday. I will not be in here tomorrow during class. I might show up toward the end if we get done testing in time. If not, you are to be working silently or with a partner, but very quietly. Okay? Go ahead and get started on your homework.